Algebra 2, this is section 2, properties of real numbers. Reminder, a real number it includes everything that we talk about. It's positives, it's negatives, it's decimals, it's fractions, it's the integers, the whole numbers, the natural numbers, and irrational numbers like root 2 and pi or root 5. It's all the numbers we work with. Most of the time, we work with the real numbers. So these are the properties. Now, I introduce this slightly differently than the book. So the first thing I want you to do is know what an identity is. An identity is an element. In this case, we're just going to say number. It's a number that under an operation doesn't change another number. Now, it has to work in either order too. For example, with addition, 0 is the identity because 0 plus 1 is 1. It doesn't change the number. Or 1 plus 0 is 1. So an identity does not change a number under an operation. So for multiplication, the identity is 1. Because when I take 1 times 10, I get 10. Or 10 times 1, I get 10. So for addition, the identity is 0 because it has no effect on a number, doesn't change it. For multiplication, the identity is 1 because, again, it doesn't affect a number, has no effect at all. The inverse, and again, I'm explaining this slightly differently because I'm doing abstract algebra here. The inverse is the number, it's the element, but in our case, the number that under an operation gives you the identity. So for addition, the identity is 0 because 0 has no effect. And the additive inverse of 5 is negative 5 because you get the identity. The additive inverse of n is negative n because you get the identity. The additive inverse of negative 7 is positive 7 because you get the identity 0. For multiplication, same idea. Remember, the identity is 1 because 1 has no effect under multiplication. And the inverse is the number that under multiplication gives you the identity. So for 8, it's 1/8 because 8 times 1/8 is 1, the identity. Or for negative 8, it would be negative 1/8 because, again, you get 1, positive 1, the identity. For n, it's 1 over n because you get 1, the identity. And they do some examples here, and we're almost done. Some more properties here. Closure property is a simple idea that if I add two real numbers, I get a real number. If I add two natural numbers, I get a natural number. The natural numbers are closed under addition. If I add to or multiply, say, two integers, I get another integer. Integers are closed because, again, when you add them or multiply them, you get another integer. The real numbers are closed. Commutative property, you've talked about this in algebra. It's the idea that some operations, the order doesn't matter. 7 plus 11, 11 plus 7, same thing. I can flip around addition. I can flip around multiplication. 7 times 11 is 77, and 11 times 7 is 77. Not all operations are commutative. For example, division and subtraction, neither one are commutative. The associative property is a regrouping. It's when I can move the parentheses and change the order that I'm doing things in, and I get the same answer. Addition and multiplication are associative. If I add the 5 and the 3 or first, or I add the 3 and the 7 first, it makes no difference. I get the same answer. Distributive property, you've talked about that a lot. The idea that if I am multiplying, in this case, 5 times two numbers that are added or subtracted, I can multiply the 5 to both, and I get the same answer. We do that all the time in our head. Like if I take 4 times 44, I can take 4 times 40 and 4 times 4 and add them together. So 4 times 40 is 160. 4 times 4 is 16. It's 176. And that is it for this section. So are these a big deal? Well, it's not something we talk about all the time, but the idea of the inverse and identity come up in mathematics occasionally. And these properties we definitely use, but we don't talk about them that much. Distributive probably the most of all.